series Programming in C. In this series, today's session we will be looking on multi-dimensional arrays and we will learn about dynamic array initialization. So, let us start with multi-dimensional arrays. We will be learning about the definition, syntax and example with respect to multi-dimensional array, and we will take an use case and we will work out on how it can be implemented using a multi-dimensional array as a real world example, and then we will learn about dynamic array initialization, how memory can be allocated for an array dynamically. So, also we will look into the examples how it can be done in this particular module. Moving further, we have already learnt about the two dimensional arrays in the previous session. This is again one more multi-dimensional array. There are only two types of definition in arrays, which are one dimensional arrays and multi-dimensional arrays. A one dimensional array will allow us to store the values in a sequential way in a contiguous memory location, whereas two dimensional array will allow us to create it as a table or a grid and with the rows and columns. So, the row size and the column size can be defined based on that how many number of elements that can be stored and accessed in the two dimensional array, it is defined. Two dimensional arrays are also one type of multi-dimensional array. However, if we want to go for increasing the size of the array, so a multi-dimensional array especially we call with the array with two or more dimensions. Say for example, in the example what we are able to see, char box of 3 will define a two dimensional array, and box of 2 1 will declare again a two dimensional array with the number of rows to be 2 and number of columns to be 1. The first dimension can even be omitted. Even then, based on the values, the compiler will be able to check with the number of values and it will be able to assume that how many number of values are to be considered for row size. What if we need the arrays with several dimensions? So, here what is the example which we can see here? It is a three dimensional array. So, here we can see the values are represented with three numerals, which is actually the dimensions. So, this will be the order or the table or the layer number, and this will be the row number and column number of each table. So, here what we can say according to this example is that 7 rows, you can have 7 rows and max depth number of elements as columns. So, likewise we can go for having 4 tables or 4 layers. So, we can either call it as layers or tables. So, according to this example given, we can see that there are layers here. So, there are 3 layers here, each layer will be having 4 rows, row number 1, row number 2, row number 3, row number 4 and 3 columns 1, 2, 3. So, if I want to define an array for this structure representation, I can go for defining the array as int array of how many number of layers. So, layer number I go for representing 3 and how many number of rows, row value it is going to be 4 and how many number of columns in each row. So, which is 3. So, this is how I can define a 3-dimensional array. So, we will now learn how 3-dimensional array will help us apart from having 2-dimensional arrays and how where actually it is being applied. So, let us take a case study. I will clearly explain this case study. The problem given to us is to find the best way to build a cellular network. So, the marketing data is given to us at 3 times of interest. there are only 10 transmitters and there is a need for a program to help analyzing the call demand data. So, we are supposed to analyze the call demand data. So, we will be provided with 3 matrices which shows the traffic density of each time of the day. So, the input will be 3, this is a 2-dimensional matrix with commuters, this is again one more 2-dimensional matrix Salesforce, this is one more 2-dimensional matrix weekend. So, all 3 matrices will be given as input and output we are supposed to arrive at summed data of the same matrix. So, how we are going to operate this, how we are going to analyze this. So, let us look at that. So, the simple algorithm is going to be, we are going to get the traffic data for 3 time periods and we are going to store it in 3 different matrices and get the weights from users, and what is the weightage factor we want to give for each entry, we can get the weight from the user as input. Then multiply weight by each matrix entry and store the sum in the summed data. So, this is what is the operation that we are going to do. We are going to multiply the weighting factor for each matrix entry and we are going to store it in the form of a complete cumulative data. And then we are going to find the highest valued cells in the summed data and display them as pair of location I and location j. So, exactly we are going to find out which particular cellular area will need more demand or will need more focus. So, this is what is the algorithm we are going to implement. Now, we will see how this can be implemented using a 3-dimensional array representation, right. So, we are using a function for getting the traffic data. So, we can see in the program that it uses 3 different matrices and all 3 different matrices values are being read from the user. Say for example, the first looping structure, using this it is able to get the values stored from the file as a matrix using the fscanf function, and the second set or the second matrix is going to be Salesforce matrix, which is again read from the file. The file is named as traffic file, which is operated on the read mode, because we are going to just read the data from the file stored. And again one more matrix, we are collecting the weekend data from the file again. Then now we have stored 3 matrices, we have got the values on these 3 matrices: commuters, Salesforce and weekend. Now, let us see how we are able to calculate the values. So, here you can see that if it is going to be a 3D array or 3-dimensional array, the conceptual structure, it is like it will be having a additional layer or additional depth or additional table, and rows and columns for each table have to be mentioned. The memory structure will be the contiguous memory location as in the case of 1 and 2D arrays. So, all which we have to do is we should learn the access method, how to store the values onto a 3-dimensional array and how to retrieve the values or access the values of a 3-dimensional array. As I already told you, these are represented as layers. So, here you can see layer 1, layer 2, layer 3. Supposing if I want to access the value 201, 201 value is available with row number 0, column number 1 of layer 3 or array 3. See, each one is an array, array 1, array 2, array 3. In the third array, in the row number 0 and column number 1, we can have an access to the particular element. So, this is how the 3-dimensional arrays are being accessed. Then we learn how to declare the 3-dimensional array. So, the syntax is data type, array name, size 1, size 2, size 3. Size 1 represents the number of 2D arrays, size 2 represents the number of rows and size 3 represents the number of columns. So, in the first case, like in this case, if I want to create an array, so how it can be done? I need to make it as an int array of number of layers. So, number of layers is 3 and number of rows is again 3, number of columns is also 3. So, this is a way I can declare an array for this case. Okay. Then how many number of elements that can be stored in that 3-dimensional array? It is nothing but if I am declaring it as 2, 3, 4, 2 layers, 3 rows, 4 columns, then I can calculate the values as 2 into 3 into 4 as the number of values that can be stored in the array. Right. Now, how we are going to access the elements? See, in the case of a 1-dimensional array, we used a single for loop. In the case of a 2-dimensional array, we used 2 for loops. In the case of 3D arrays, we will be using 3 for loops, one for the layer number, one for the row number and one for the column number. Instead of mentioning that as layer, we can even make the representation, we can even call the representation as table. So, here you can see that the elements are accessed using 3 indices. The indices will be depth, row and column positions. So, for access an element 14 in the previous example, or say we are trying to store the first table having the values from starting from 0 to 11 continuous values. Okay. And in the second table we are storing the values from 12 to 13. Now, my task is to store or access the element 14. So, how we can access the element 14? The index of the first table is 0, the index of the second table is 1, right. Then the row index of the number 14, the row index of the number 14, it is going to be 0, 1, 2. So, the row index we have to calculate and the column index would be 0, 1, 2, 3. So, when I want to access the value 4, when I want to represent the value 14, so my row my table index will be or depth index will be 1, my row index will be 0 because it exists in the 0th row, and my column index would be 2 because it exists in the second column, 0, 1, 2, 3 second column, right. So, if I want to represent value 14, I should use it as x of 1 depth 1 0 column row 0 2 column 2. Okay. So, this is how we can access single element in the 3-dimensional array. Supposing if you want to access all the elements of a 3-dimensional array, if you want to print the 3-dimensional array in the form of a tabular structure or in the form of a layer structure, then we can make use of the 3 nested loops, since we are going for 3-dimensional array. So, the first loop will be used to represent the layer value or table. Second for loop will be used to represent the row representation, and third will be for column representation. According to the example taken, so here we have assumed that the depth value is 2, number of rows size is 3 and the column size is 4. So, here we can see that the loop will be terminated with the corresponding control variables 2, 3 and 4 according to the number of tables, number of rows and number of columns, right. Supposing if I am going to use how the particular element can be accessed, if I have to print the values of all the elements in the array. So, how I can do it? I can represent this way. Instead of 2 square brackets, we will be using 3 square brackets. So, when I have to print all the values of the particular 3-dimensional array, I will be using printf %d. Anyway, it's going to be a single value even if it is of 3 dimensions, right. So, x of I j k. So, this will allow us to print all the values that are stored in the 3 dimensional array. I hope now you are able to understand how the 3D array is being organized and how it is being stored in memory and how it can be accessed through the index representations or through the subscript representation. In some cases we will be using the term depth, in some cases layer or table, all are the same, right. Now, we will move on to the way that how memory allocation is being done for arrays dynamically. So far all our examples have allocated variables statically, in the sense that before declaring or before initializing the values to the array, we have given the compiler an idea that what is going to be the size that it is going to deal with the elements in an array. I am defining the size prior to the use of the array. So, that is what is static allocation. So, compiler will be able to understand that if I am defining the row size to be of 3, the compiler will be able to understand that yes, it needs 3 contiguous memory locations. So, it will allocate 3 contiguous memory locations prior to the execution of the program. That is what is static memory allocation. Suppose in some cases, if the user does not be able to determine the size of the array statically, that means before the execution of the array, before the execution of the program, then we may have to define the array size dynamically at runtime. While executing the program only, I will come to know that what would be the size of the array required. So, that is what is called dynamic memory allocation. So, how that could be done? Generally, we will have to be representing the size of the array while defining the array, but here I do not know or I am not aware of how many elements are going to be there or how many elements are going to be processed in that particular execution. Then simply I will define the array using the pointer as int asterisk the array name, and I have to use a method or a function called CEC-UGC. This will allocate the memory locations dynamically upon execution of the program only. By getting the inputs from the user, the requested count will be given to the allocation function, CEC-UGC function. Then it will be able to allocate these many number of bytes I need for declaring the array. So, that could be given at the time of runtime. So, the main function will be executed, the main function would come to know that these many bytes I may need to assign for declaring an array. So, by that time it can have a function to allocate the size. The CEC-UGC function will work in such a way that what is the count which is required, that should be given as input, and what is the size of the particular int type variable has to be given. So, according to the size of int, it will be able to allocate the number of bytes to the particular array. If it can't allocate the requested count, supposing if I am asking for the requested count of having the memory locations more than the one which is available, so then CEC-UGC would not be able to allocate a location, then it returns null in this case. Or otherwise, if the memory is allocated, it will be able to give the pointer from which particular location or which number of how many number of bytes can be allocated. Once it is allocated, then this array will be associated with that particular location. So, it is a best practice of programming that once the pointer is associated with the dynamic memory location, at the end of the program or at the time of completion of the execution, the pointer should be freed using the free function, or otherwise the allocated memory would remain with the particular pointer allocated, and it is mentioned with the status of occupied, so that the other programmers, if they try to allocate, if they try to find memory location which may not be possible for them to do, so it is a best practice to free the memory which is allocated. We will look into the memory allocation functions. M-alloc function. M-alloc function will allocate the number of bytes required in the case of a variable. So, in the case of a variable, what type of variable it is, accordingly the memory requirement can be given and it can be allocated. Similar to the C-alloc function, it returns a pointer to the beginning of the block. So, this is a syntax of the M-alloc function. In case if I am requiring a char type value to be stored, M-alloc can work on the char type. Char will occupy 1 byte of memory location. So, size of char would be computed, and how many number of characters we want, that should be mentioned using the value n. So, how many number of characters you want to use using the particular char type variable, then accordingly the number of characters or the memory will be allocated. This is a simple example of using M-alloc function. So, here you can see that there is a variable n declared and there is a pointer variable p declared. So, here we can see that inside the say conditional statement, we are declaring a pointer m and the memory is allocated to m, right. So, whatever the size we are going to request for, accordingly the memory would be allocated, and star m equal to 20. So, we are requesting for 20 memory locations, then the pointer p would be assigned with the m value, so that thereby p will be using the locations which are allocated. M can now be destroyed. So, how the free function works? So, here we can see that the allocated memory locations will be given with the status of occupied by the compiler. So, on clearing, or there is a way of making it as a garbage. So, the garbage has to be cleared once it is occupied. Then we need to make use of the free function. We need to supply the pointer which is associated with that memory location as input. So, then the occupied or the allocated memory would be cleared from use, and so that it will be allowed for the use from the other users. And C-alloc is also a memory allocation function which is especially used for arrays. So, C-alloc should be used. Here we need to mention how many number of items we want to go for, because it is specifically for an array. So, an array is a collection of elements. So, we need to mention for how many number of elements we want the dynamic allocation to be done. So, here we can see the example of using M-alloc and C-alloc as the same, but one slight difference here is that C-alloc initializes every bit to 0. C-alloc is a function specifically used for arrays. So, which will initialize every bit to 0 on allocating the memory. Also, it is slower than M-alloc function. So, for some situations, if we want faster execution to be done, it is better to go for using M-alloc, and for appropriate allocation we can make use of the C-alloc function. And assume that we have allocated the array with 20 locations, and if you want to revise it or if you want to resize it, if at all if I want to expand the number of elements, reducing may not be required, because even if the array size is more than the required one, it does not matter. You can accommodate, you can make the array to be free if it is not occupied. That is not a issue with the reducing part if it is going to be lesser. However, if the memory is to be extended, then we will have to look into it, because we have the time of execution, we have for the first execution we have assumed that 20 elements may be required, but on the execution we came to know that it requires 40 elements, 100 elements. Then how to expand? the memory dynamically. So, for that we need to use the function called realloc. So, realloc function uses the first parameter to be the pointer which is already existing. Remember, this should be an existing pointer because realloc can be applied only for the allocated memory. If we have already allocated and if you want to revise it or resize it or extend the locations, then we may have to use a realloc function. So, obviously, this pointer will be an existing pointer which is already allocated with dynamic memory. And then the size, new size, already the size may be, the number of locations which are allocated may be 20. If you want to increase the size, we have to mention what is the size you want to expand the memory. So, new size have to be mentioned. So, obviously, this is an interesting function that whatever we have already assigned the values in the array priorly or prior to the extension of the memory, it would automatically be copied to the new larger locations also. Say for example, if I am having 20 elements in the array and I have also stored those 20 elements starting from the index 0 to 20. Now, I want to increase the size of the array by 40 on reallocation. So, what happens? On reallocation, it starts from 1 and it extends up to 40, but the 20 elements which will be copied to the first 20 locations by default, and the new 20 locations are allowed to go with new elements. So, this is one interesting feature of realloc function. So, here we can see an example use of a realloc function. So, already the memory allocated, it is with 2 elements. So, now we are increasing the elements by 3. This is a new size. So, we can see that even after reallocating, we can see that if you try to print 3 elements, it can be done. See to that, clear the allocation by using free function. So, on summarizing this session, we have learnt the way that how multi-dimensional arrays can be used, especially focusing more on 3D arrays. So, 3D arrays, we have considered 3 dimensions as depth, rows and columns. We have learned how to store elements onto a 3-dimensional arrays and how to access the elements, and we have also seen some programs working out with the real time scenario for arriving at the 3D arrays. Also, there is a memory allocation required for arrays, especially or dynamically. So, how we can dynamically increase the size of the array, we have seen with malloc, calloc, realloc and free functions. So, thank you for listening to this particular session and making use of the knowledge. Thank you.